So we'll continue with our discussion. So we are going to see about the passive IC components, and predominantly, it is going to be R, L, and C. So you know that these components are not going to work as they were working at low frequencies. So you have to modify their design to accommodate them at high frequency. For example, one issue you see here, inductor values larger than 10 nanohenry, they become larger in size. When the size is going to increase, they are going to have poor quality factor. So the way in which the efficient way in which they are going to work is going to be poor. And they, instead of resonating with other capacitance, they have self resonating characteristics. So these are the simple issues we face when the same 10 nanohenry inductor is going to work at low frequency and it is going to work at high frequency. And capacitance, you see, when you are going to have a very high quality factor, the low temperature coefficient capacitance are available, but the tolerance is very loose. So 20% tolerance you have to give because the value is going to vary in a huge range. So I cannot say the capacitor value 1 microhenry. I cannot say it is going to be 1 microhenry always. No. It is going to change based on the frequency. That is one thing which is a point of concern. Also, most area efficient capacitance tend to have high losses and poor voltage coefficient. If you compromise on area, you have to have loss, very high loss. If your area becomes very high, then this device cannot be used for a compact application, right? So a lot of issues are there with capacitance also, and resistance, you see. So resistance internally, they will have a low capacitance because they have two wires, and they have a low cell capacitance, and temperature coefficient are going to be a major factor because you have a lot of thermal noise getting added with these capacitance. And when they operate at a very high frequency, the high voltage coefficient and the loose tolerance is going to be issue. Tolerance means what is the range of the minimum and maximum value my components are going to take. So these are some of the issues we have seen RLC, how the fabrication is going to be an issue at high frequency, how the parameters of them are going to be challenging at high frequency. So we are going to see what alternative structures are there, what we can propose for RL and